Hello students. Now we will take a problem from NCERT book, okay, physics book. Now here we have a question where we have conversions being there, kilometer per hour to meters per second, and acceleration in different conversions units and all those things. So we will discuss this. It will be a bit long video. Let us look at it. Okay. So the question is something like this. A car is moving along a straight highway with a speed of 127 km per hour is brought to a stop within a distance of 200 meters. What is the retardation of the car and how long does it take for the car to stop? As usual, we will write the three equations of kinematics. Okay. So another one is S is equal to ut plus half at square, and the one is v square is equal to u square plus 2as. This continuous repetition is very much required. Okay. So given, what is given here? A car is moving at a speed of 127 km per hour. That is, initially when we see it, it is moving with 127 km per hour. That means the initial velocity u is 127 km per hour and is brought to a stop. It means the final velocity is equal to 0 km per hour and it stops within a distance of 200 meters. S is equal to 200 meters. What is asked? When you see what is asked is what is the retardation? Retardation means acceleration is asked. And how long does it take for the car to stop? Means time is asked, right? So let us see the first equation. Here anyhow v and u is given, but both a and t is not given, so we will not use this equation. In the second equation also a and t is not known, so we cannot use this equation. What remains is the third equation. V is given, u is given, s is given, a is asked, so we use this equation. But the point is that which unit should we use for velocity? Should we use kilometer per hour or should we convert it into meters per second? Now let us continue with this kilometer per hour. Why? Because when you say velocity, what is the dimensional formula for velocity? It is LT raised to minus 1. So L can be any length units, T can be any time units. And when you consider acceleration, what is the dimensional formula? It is LT raised to minus 2, right? So we will keep the same thing here, okay? So L we are taking in kilometers and T we are taking in hours, okay? So this has to be very clear to us that L is in kilometer and T time is in hours, okay? So with that in mind, we will see v square is equal to u square plus 2as. So consistent units has to be used. So v is 0, so 0 square. U is 127 square plus 2 into what is acceleration? Unknown. What is s? We are not supposed to put 200 here because we are using a length units as kilometers, not in meters. So we have to convert the length units which is in meters to kilometers. So we have 1000 meters is 1 kilometers. Then 200 meters would be what? Right. So it is cross multiplication as we have done. We have understood in your high school. So it is 200 divided by 1000 which is equal to 0.2. So we are going to substitute 0.2 kilometers, and like this we are going to solve, and we see that the 127 square will come as 15876 plus 2 into a into 0.2. So we will put here 0.4, right? 2 into 0.2 is 0.4. So now if you consider a, acceleration would be minus 15876 divided by 0.4, and what I've got the answer is 39,000 minus negative 39,690 kilometer per hour square. Understand the students, it is kilometer per hour square. Okay, very important one. How is that? Because length per time square. So what we have got it? We have got acceleration as minus 39,690 kilometer per hour square. This would be our acceleration answer in kilometer per hour. Now, in case the question is in meters per second, then we should be able to convert acceleration, which is equal to 39,690 kilometer per hour square, right, into, we have to get it in meters per second square. Let us understand how to do that. So, here we have to understand it is 39,690 into, instead of kilometers, we want in meters, is it not? Kilometers we have to write in meters, right? 1 kilometer is how much? 1000 meters, right? And then hour, 1 hour is equal to 60 minutes, and each minute is equal to 60 seconds. So together it comes to 3,600 seconds. So what happens? 1 hour is equal to 3,600 seconds. So this is 1000 divided by 3,600. But then 3,600 seconds, yes. But here we are doing hour square. I'm sorry, I missed it here. So hour square. Now when you do hour square, you see, when you say 1 hour square, it means this 1 hour is 3,600 second square. This implies this is 3,600 square second square. So here it should be 3,600 square. I hope you are understanding this, students. So our acceleration, when I calculated this, what I got was 3.0833 meters per second square. This is the conversion, okay? But now we will concentrate on hours and kilometers, okay? So we have acceleration. What is important for us, next question here is that how long does it take for the car to stop? We have to find out the time, is it not? Let us take the time. So time here, how do we calculate? Again, V is equal to U plus AT. We can easily calculate time here. So let us use this. What is V? V is 0, right? So I'll write it again. V is equal to U plus AT. V is 0. U is 127 kilometer per hour plus acceleration. We have calculated it is minus. We have missed this minus here. There has to be a minus here. So acceleration is minus 39690, right, into time t. So what we have to do, we have to find out this. So we can find out like this. We can write this as 127. We will put it on the other side, okay. So we will have this as t is equal to 39690 divided by, we will have it as 127. So when we do that, we get the answer as 0.003199 kilometers. No, it's not kilometers, it is hour, because time is, we are using hour. So time is equal to 0.00319 hours. But 1 hour is equal to 3,600 seconds. So we can write this as 0.03199 into 3,600. This comes out to be 11.516 seconds. So this is the total time taken. Now we have used this kilometer per hour and meters kilometer per hour as the units, right? So if we had directly done this without this, it would have been easier. For example, when you said v square is equal to u square plus 2as, this is the equation we have used, we could have converted u, which was 127 kilometer per hour, into meters per second. How do we do that? We know 127. Instead of kilometer, we have to substitute meters, so it is 1000 meters. Instead of hour, I have to put 3600 seconds. 1 hour is 3600 seconds. So when I do this calculation, what I get is 35.28 meters per second would be the speed. Okay, so 35.28 meters per second would be the speed. And now this we can substitute here back. Velocity is 0. This would be 35.28 square plus 2 into a, we do not know, s. Now here we have to be careful that we have to put 200 meters because our unit is meter and second. So you should not put it as 0.2 here. So when we do that, we get acceleration as 3.11 meters per second. Now if you see over here, you get the almost same answer, right? You get 3.088 here, and here you are getting 3.11, obviously with a negative. Okay. Now the question arises, sir, why is that a bit of difference? There we had got 11 point, when we did the conversion, we got it as 11 point, we got acceleration as 3 point, yes. So we got the acceleration in the previous case as 3.0833 meters per second square. When we did we calculated acceleration using kilometer per hour square and then converted. Now the problem here is we are actually truncating some part of the answers, right? So if it was 3.1999, we would leave that 9, or we would make it round off and all. Those things are actually making this difference, right? Next we have to put the v is equal to u plus at, and here this is v is 0, u is 35.28 minus or plus minus 3.11 meters per second square, and multiplied by the time. Time we do not know, we have to calculate. This would come as 35.28 divided by 3.11, and this comes out to be 11.34 seconds, right? So in competitive exams, you will have an option there, whichever is closer to the answer what you have got, you can click it. Or if it is a numerical assessment type, in the sense there is a dash and you have to substitute that, then they will keep a range for it, which calculates the, which takes into consideration the rounding off and the truncations error which is possible. So I hope you have enjoyed this video, students. If you have any doubts, you can put it in the comment box and I will be happy to answer. Thank you very much.